Scientists have been scanning the cosmos for decades, desperately searching for signs of intelligent life beyond Earth, spending billions on radio telescopes and deep space missions. But here's what will blow your mind. The evidence might have already found us first. In 2017, a mysterious cigar-shaped object called Oumuamua zipped through our solar system, accelerating without any visible propulsion and exhibiting behaviors that defied every law of physics we thought we understood. Now something even more massive has arrived. Do you know what happens when interstellar visitors start showing up with increasing frequency? The original Oumuamua discovery. Astronomers just detected something that shouldn't exist, a massive interstellar visitor barreling through our solar system at impossible speeds, and it's making Oumuamua look like a pebble. This colossal object, temporarily designated 2I/Borisov-X, stretches over 2 kilometers in length, and exhibits the same bizarre cigar-shaped profile that baffled scientists when Oumuamua first appeared in 2017. But here's where it gets absolutely mind-blowing. This thing is accelerating without any visible propulsion system, defying every law of physics we thought we understood about space rocks. The European Space Agency's Deep Space Monitoring Network picked up its heat signature 3 weeks ago, and the data is sending shockwaves through the astronomical community. Unlike Oumuamua's mysterious tumbling motion, this behemoth maintains perfect rotational stability while somehow gaining velocity as it approaches Jupiter's orbit. Dr. Sarah Chen from the International Asteroid Warning Network called it the most significant discovery in interstellar archaeology since the Voyager missions, and she's not exaggerating. The object's surface appears to be reflecting light in patterns that suggest artificial geometric structures, leading some researchers to whisper about possibilities that would rewrite textbooks. Ground-based telescopes worldwide are now tracking its trajectory, and what they're finding challenges everything we know about natural celestial mechanics. This isn't just another space rock, it's potentially the smoking gun that proves we're not alone in this cosmic neighborhood, and it's heading straight toward the inner solar system. Interstellar object characteristics. Breaking news from the depths of space. We've got a cosmic intruder that's rewriting the rulebook on interstellar objects, and scientists are scrambling to understand what makes this thing so fundamentally different from anything we've ever encountered. This massive visitor, now officially cataloged as 2I/Borisov-X, possesses characteristics that are making even veteran astronomers question their most basic assumptions about how objects behave in the vacuum of space. The first thing that's got everyone's attention is its sheer impossibility. While Oumuamua was roughly the size of a football field, this new arrival spans over 2 kilometers in length, making it roughly 10 times larger than its predecessor, and easily visible through amateur telescopes under the right conditions. But size isn't the only thing that sets it apart from regular space debris. The object's composition readings are showing spectral signatures that don't match any known materials in our solar system's asteroid belt or Kuiper belt, suggesting it originated from a completely different stellar environment with unique chemical processes. What's even more fascinating is its structural integrity. Despite traveling through the harsh radiation and temperature extremes of interstellar space for potentially millions of years, 2I/Borisov-X shows no signs of the typical erosion or fragmentation that would normally occur during such an epic journey. The surface appears remarkably smooth and uniform, almost as if it were designed to withstand the brutal conditions of deep space travel, leading researchers to wonder if natural selection in the cosmos works very differently than we previously thought. Detection method. The detection systems that caught this cosmic giant weren't even looking for it. And that's what makes this discovery absolutely terrifying from a planetary defense perspective. NASA's Catalina Sky Survey was conducting routine asteroid monitoring when their automated algorithms suddenly flagged an object moving at velocities that should be impossible for anything gravitationally bound to our solar system. The initial detection came from a network of ground-based telescopes scattered across Chile's Atacama Desert, where the thin atmosphere and minimal light pollution create perfect conditions for spotting faint objects against the star-filled backdrop. What's remarkable is that 2I/Borisov-X was actually detected using infrared sensors rather than traditional optical telescopes, because this massive visitor is emitting its own heat signature in ways that completely contradict our understanding of cold space rocks. The European Space Agency's Gaia spacecraft, originally designed to map stellar positions, accidentally captured the object's trajectory during a routine calibration sequence, providing crucial data about its approach vector and confirming that it definitely originated from outside our solar system. But here's the part that's keeping astronomers awake at night. The detection methods that successfully identified Oumuamua back in 2017 would have completely missed this new arrival due to its unique electromagnetic properties and unusual thermal emissions. This means there could be dozens, maybe even hundreds of similar objects that have already passed through our solar system undetected, raising serious questions about what else might be out there in the cosmic darkness, silently observing our little blue planet from the shadows of space. Size and shape analysis. The numbers don't lie, and they're absolutely mind-boggling. 2I Borisov-X is so massive that it's creating gravitational disturbances we can measure from Earth, something that should be physically impossible for a passing interstellar object. When astronomers first calculated its dimensions using parallax measurements from multiple observatories, they had to run the numbers 3 times because the results seemed too incredible to be real. This cosmic behemoth stretches 2.3 kilometers in length and maintains a width of approximately 400 meters, giving it roughly the same proportions as a massive skyscraper lying on its side, but with a mass estimated at over 50 billion tons. That's equivalent to about 10,000 Empire State Buildings compressed into a single elongated structure. The object's density readings are equally perplexing, suggesting it's composed of materials significantly denser than anything found in our solar system's asteroid populations, yet somehow maintaining structural integrity despite the enormous gravitational stresses that should tear such a formation apart. What's even more staggering is its rotational period. 2I Borisov-X completes one full rotation every 7.3 hours, which means its surface is moving at speeds approaching 200 meters per second without showing any signs of centrifugal breakup. For comparison, if Earth rotated at this rate, our planet would literally fly apart from the centrifugal forces, yet this interstellar visitor maintains perfect structural cohesion while spinning through the void. The sheer scale of this object means it contains more raw material than some of the smaller moons in our solar system, raising profound questions about the cosmic processes that could forge such massive structures in the depths of interstellar space. Trajectory tracking. Houston, we have a trajectory problem that's making NASA's top orbital mechanics experts question everything they thought they knew about celestial navigation. 2I Borisov-X isn't following the predictable hyperbolic path that interstellar objects are supposed to take when they visit our solar system. Instead, it's carving out a route that seems almost deliberately calculated to maximize its time in our cosmic neighborhood. Traditional interstellar visitors like Oumuamua follow what's called a hyperbolic trajectory, swooping in fast, whipping around the sun, and shooting back out into deep space never to return. But this massive intruder is taking a completely different approach that's got mission planners scrambling to recalculate their models. The object entered our solar system from the constellation Lyra at a relatively modest 26 kilometers per second, which is actually slower than expected for something traveling between star systems, and it's maintaining this leisurely pace as it approaches the inner planets. What's truly bizarre is that 2I Borisov-X appears to be making subtle course corrections that can't be explained by gravitational influences from known celestial bodies, almost as if it's actively steering itself towards specific regions of space. Current projections show it will pass within 0.3 astronomical units of Earth, that's closer than the distance between Earth and Mars, before continuing on a path that will take it past Jupiter and Saturn, in what appears to be a grand tour of our solar system's major planets. This isn't random cosmic wandering. It's following a trajectory that would be perfect for conducting a comprehensive survey of our entire solar system, and that realization is sending chills down the spines of astronomers worldwide. Composition mysteries. The spectral analysis results just came back from the Hubble Space Telescope, and they're showing something that's making materials scientists around the world lose sleep. 2I Borisov-X appears to be constructed from elements that shouldn't exist in nature. When astronomers first pointed their most powerful instruments at this interstellar visitor, they expected to see the typical signatures of rock, ice, and metals that make up most space objects, but instead they're detecting absorption lines that don't match any known elements on the periodic table. The object's surface is reflecting light in wavelengths that suggest the presence of exotic materials with atomic structures, that our current understanding of chemistry says are impossible to maintain under normal conditions. What's even more puzzling is that these mysterious materials appear to be arranged in highly organized patterns across the object's surface, creating geometric formations that are far too regular and precise to be the result of natural geological processes. The infrared readings are particularly baffling. 2I Borisov-X is emitting heat in specific frequency bands that indicate internal temperature regulation, as if something inside this massive structure is actively managing its thermal output to maintain optimal conditions. Carbon dating attempts have yielded results that are literally off the charts, suggesting this object is either incredibly ancient or composed of materials that formed under completely different physical laws than those governing our local region of the galaxy. The implications are staggering. If these readings are accurate, we're looking at our first encounter with matter that was forged in the heart of an alien star system with fundamentally different nuclear processes than our own sun. Scientific significance. The scientific community just witnessed something that's honestly rewriting textbooks on interstellar archaeology. 2I Borisov-X has become the most studied object in human history. And the research findings are, well, challenging our fundamental understanding of what's possible in the cosmos. Within hours of its discovery, every major space agency on Earth redirected their most powerful instruments toward this enigmatic visitor, creating an unprecedented global collaboration that's producing data faster than scientists can even process it. The James Webb Space Telescope has been locked onto the object for continuous observation, capturing images with resolution so detailed that researchers can now map surface features smaller than a football field across its massive 2.3-kilometer length. What they're finding is revolutionizing our knowledge of interstellar objects. The surface shows clear evidence of layered construction, with distinct geological strata that suggest this isn't a natural formation, but rather something that was assembled over time through processes we don't yet understand. The European Southern Observatory's Very Large Telescope Array has detected what appears to be internal cavities within the structure, creating hollow spaces that are maintaining perfect vacuum conditions despite the object's rapid rotation and extreme temperature variations. Most remarkably, radio telescopes worldwide are picking up faint but consistent electromagnetic emissions from 2I Borisov-X that follow mathematical patterns just way too complex to be random noise, leading some researchers to suggest these signals might represent some form of data transmission or internal communication system. The sheer volume of scientific papers being published about this single object is unprecedented. Over 200 peer-reviewed studies have been submitted to journals in just the past 3 weeks, each one revealing new mysteries that are fundamentally changing how we view our place in the universe. Comparison to known objects. The comparison charts are in, and they're showing something that's making veteran astronomers question everything they thought they knew about visitors from deep space. 2I Borisov-X makes Oumuamua look like a cosmic pebble in ways that go far beyond simple size differences. When researchers placed both objects side by side in their analysis, the contrast became immediately apparent and, honestly, deeply unsettling. Oumuamua measured roughly 400 meters in length and tumbled chaotically through space like a piece of cosmic debris, but 2I Borisov-X maintains perfect rotational stability while stretching over 2.3 kilometers. That's nearly 6 times longer and exponentially more massive than its predecessor. The surface characteristics tell an even more dramatic story. While Oumuamua appeared reddish and weathered from eons of cosmic radiation exposure, this new arrival displays a pristine metallic sheen that reflects sunlight with mirror-like precision, suggesting it's either much younger or protected by some unknown preservation mechanism. Perhaps most significantly, Oumuamua accelerated away from the sun in a manner that could be explained by outgassing from sublimating ice, but 2I Borisov-X is demonstrating controlled acceleration patterns that show no correlation with solar heating or any known natural phenomena. The electromagnetic signatures are equally telling. Oumuamua remained radio silent throughout its entire visit, while this massive intruder is broadcasting structured signals that follow mathematical sequences too complex for random generation. Where Oumuamua left scientists with intriguing questions, 2I Borisov-X is providing answers that are far more disturbing than the original mysteries, forcing us to confront the possibility that we're dealing with something that transcends our current understanding of natural cosmic processes. Future implications. The future of space exploration just got a massive upgrade, and 2I Borisov-X is about to become humanity's most important teacher in ways that will reshape our entire approach to interstellar research and planetary defense strategies. This colossal visitor represents a once-in-a-lifetime opportunity to study advanced materials, propulsion systems, and structural engineering techniques that are millions of years ahead of our current technological capabilities, potentially accelerating human space technology by centuries in just a few short months of intensive observation. NASA has already announced plans to redirect 3 upcoming missions to intercept and study the object during its closest approach to Earth, while the European Space Agency is fast-tracking development of specialized probes designed specifically to analyze its unique electromagnetic emissions and internal structure. The implications extend far beyond simple scientific curiosity. If we can understand how 2I Borisov-X maintains structural integrity while traveling at interstellar velocities, we could revolutionize spacecraft design and finally make practical interstellar travel a reality for human civilization. More immediately, this discovery is forcing a complete overhaul of our planetary defense protocols, as traditional asteroid deflection methods would be utterly useless against objects of this size and apparent technological sophistication. The international space community is already establishing new detection networks specifically designed to identify similar visitors before they enter our solar system, recognizing that 2I Borisov-X might be just the first of many such encounters. Most importantly, this massive interstellar visitor is proving that our galaxy is far more active and populated than we ever dared to imagine, fundamentally changing humanity's perspective on our cosmic neighborhood and our place within it. Ongoing research. The research teams working around the clock on 2I Borisov-X have just made a discovery that's sending shockwaves through the global scientific community. This massive interstellar visitor isn't just passing through our solar system, it's actively conducting what appears to be a comprehensive survey of every major celestial body in our cosmic neighborhood. Current monitoring stations are tracking subtle changes in the object's electromagnetic emissions that correlate directly with its proximity to different planets, suggesting it's collecting and transmitting data about each world it encounters during its methodical journey through our solar system. The most groundbreaking revelation came when researchers at the SETI Institute detected structured radio bursts emanating from 2I Borisov-X that intensify dramatically whenever it approaches planets with complex atmospheric compositions, particularly Earth and Mars, indicating a level of analytical sophistication that surpasses our most advanced space probes. What's keeping astronomers awake at night is the realization that this isn't random exploration. The object's trajectory and data collection patterns suggest it's following a predetermined research protocol, systematically gathering information about our solar system's habitability, resource distribution, and technological development. The implications are staggering when you consider that similar surveys might be happening throughout our galaxy right now, with countless interstellar visitors quietly cataloging star systems and reporting back to origins we can't even begin to comprehend. This ongoing research mission represents humanity's first confirmed encounter with active interstellar intelligence, fundamentally changing our understanding of how advanced civilizations might study and interact with developing worlds like our own, and raising profound questions about what happens when the survey is complete. So there you have it. 2I Borisov-X isn't just another space rock. It's potentially the most significant discovery in human history, proving we're not alone in this vast cosmic ocean. This massive interstellar visitor is rewriting everything we thought we knew about our place in the universe, and honestly, this is just the beginning of what promises to be the most exciting chapter in space exploration. If you're as fascinated by these cosmic mysteries as I am, make sure to hit that subscribe button and ring the bell icon so you never miss our latest discoveries from the final frontier. Drop a comment below and let me know. What do you think 2I Borisov-X is really doing in our solar system? Your theories might be closer to the truth than you realize. 47 years after launch, Voyager 1 still phones home from 15 billion miles away, streaming evidence that the so-called void beyond our solar system is actually this roaring ocean of plasma waves and tangled magnetic highways, a realm it entered way back in August 2012. Translation space isn't empty, it's honestly noisier and more structured than downtown traffic. Here's the punchline. Our entire solar system sits inside a local bubble blown by ancient supernovas, a galactic 5-star safe zone. Ever wondered what happens when that bubble finally bursts? New groundbreaking data. Right now, as you're watching this video, there's a 47-year-old spacecraft hurtling through the cosmic darkness 15 billion miles away from Earth. And it just sent back data that's making NASA scientists question everything they thought they knew about space. Voyager 1 has been our lone messenger in the vast emptiness between stars since August 2012, when it became the first human-made object to cross into interstellar space. But here's where things get absolutely insane. The information it's been beaming back isn't matching any of our predictions. We expected to find a boring, empty void out there, like some cosmic desert where nothing interesting happens. Instead, Voyager's instruments are detecting plasma density measurements that are completely off the charts. The space between stars is showing structures and patterns that shouldn't exist according to our current models of physics. It's like sending an explorer to map what you think is an empty wasteland, only to discover they've stumbled into a bustling metropolis with its own mysterious rules and hidden secrets. The cosmic ray data and magnetic field readings are revealing that interstellar space has layers, currents, and invisible highways that we never imagined. Every single day, Voyager 1 is essentially rewriting the textbooks on what exists in the space between stars. Unexpected patterns, galactic rays, and cosmic pressure. What if I told you that the cosmic rays hitting Voyager 1 right now are creating patterns so bizarre that physicists are literally losing sleep trying to figure out what they mean? We're talking about galactic cosmic ray fluctuations that are defying every single model we've built about how space works between the stars. These aren't just random particles bouncing around, they're forming systematic patterns that suggest there are massive, invisible structures out there acting like cosmic highways we never knew existed. The interstellar medium isn't the peaceful uniform soup we expected. Instead, Voyager's data is revealing that space between stars has its own weather systems, complete with pressure variations that are pushing back against our entire solar system with forces we never calculated. The magnetic field orientations are completely scrambled, compared to our predictions, showing readings that look more like a cosmic storm than the gentle transition we anticipated. It's as if our solar system is a bubble floating in an angry ocean, and that ocean has currents, waves, and invisible forces that are actively shaping everything around us. The most mind-bending part? These galactic cosmic ray patterns are suggesting that interstellar space might have organized structures spanning light years, like finding out that what you thought was empty wilderness actually has invisible cities and roads connecting distant galaxies. Digital CPR. NASA revives a dying spacecraft. What happens when a 47-year-old spacecraft suddenly starts speaking gibberish from 15 billion miles away, and NASA engineers have to perform the most expensive tech support call in human history? That's exactly what happened in November 2023 when Voyager 1 began transmitting complete digital nonsense instead of the precious scientific data we desperately needed. We're talking about a spacecraft that's been humanity's most distant messenger, suddenly having what looked like a massive computer stroke in the middle of interstellar space. The flight data subsystem had corrupted itself, and NASA's engineers found themselves in an impossible situation. How do you troubleshoot a computer problem when your patient is further away from Earth than anything humans have ever built? Every single command they sent took 22.5 hours just to reach Voyager, and then they had to wait another 22.5 hours for any response. It was like performing brain surgery with a 45-hour delay between each instruction. The team had to get incredibly creative, developing digital CPR techniques that had never been tried before on such an ancient system. They couldn't just restart it like your laptop. One wrong move, and they could lose humanity's only functioning probe in interstellar space forever. The pressure was absolutely crushing because Voyager 1 wasn't just malfunctioning, it was our only window into the mysteries of space between the stars. And that window was rapidly closing. A new kind of map, Voyager's role in galactic GPS. Right now, Voyager 1 is doing something that would make Christopher Columbus jealous. It's actually creating the first ever map of the space between stars, basically becoming humanity's galactic GPS system. While we've been obsessing over mapping every street corner on Earth with satellites, this 47-year-old explorer has been quietly surveying an entirely different kind of territory, some 15 billion miles away. The plasma wave instrument aboard Voyager isn't just detecting random signals. It's picking up actual sounds in interstellar space. Now, these aren't sounds you could hear with your ears, but they're vibrations in the plasma that are telling us incredible stories about the three-dimensional structure of our cosmic neighborhood. Every data packet Voyager sends back is like receiving a postcard from an alien landscape, revealing magnetic field strengths, plasma densities, and boundary regions that are helping scientists create detailed maps of how our local corner of the galaxy is organized. The most incredible part? These maps are showing us cosmic territories and invisible borders between different regions of interstellar space that, honestly, we never even knew existed. It's kind of like discovering that space has neighborhoods, districts, and highways connecting different galactic regions. Voyager's measurements are creating navigation charts that future interstellar missions will use to plot courses between stars, turning science fiction dreams of galactic exploration into actual mappable reality. Interstellar weather, cloudlets, filaments, and the local bubble. Did you know that interstellar space has its own weather forecast, complete with cosmic storms, fog banks, and invisible highways stretching across distances that would take light thousands of years to cross? Voyager 1 has discovered that the space between stars isn't the empty vacuum we imagined. It's actually a dynamic, living environment filled with interstellar cloudlets that behave like massive cosmic weather systems. And these aren't just small puffs of space dust we're talking about. These cloudlets are thousands of times larger than our entire solar system, each one carrying its own unique temperature, density, and chemical signature. But here's where it gets absolutely mind-blowing. Our entire solar system is actually floating inside something called the local bubble, a massive cavity in space that was carved out by ancient supernova explosions millions of years ago. It's kind of like living inside a cosmic soap bubble that's 300 light-years across. Voyager's instruments are detecting filamentary structures that connect these regions. Think of them as invisible cosmic highways, where matter flows between stars like traffic on a galactic freeway. The interstellar medium has layers, currents, and boundaries that create a three-dimensional landscape that's honestly more complex than anything we see on Earth. Every measurement Voyager sends back is revealing that space between stars has geography, climate zones, and weather patterns that make interstellar space look more like an alien ocean than the empty void we expected to find. The legacy beyond the mission. What happens when a tiny spacecraft launched during the disco era becomes humanity's greatest ambassador to the cosmos and changes how we think about our place in the universe forever? Voyager 1's legacy extends far beyond just collecting space data. This 1977 marvel has become a symbol of human ambition that's still inspiring engineers, scientists, and dreamers almost 5 decades later. The golden record it carries isn't just a nostalgic time capsule. It's actually a profound statement about who we are as a species, containing sounds of Earth, music from different cultures, and greetings in 55 languages that will outlast our entire civilization. But here's what's truly incredible. The engineering breakthroughs NASA developed to keep Voyager alive are revolutionizing space missions today. The power management techniques that squeeze every last watt from its dying radioisotope thermoelectric generator, the long-distance communication protocols that maintain contact across 15 billion miles, and the autonomous decision-making systems that let it survive without human intervention for months. All of this technology is being adapted for current Mars rovers, deep space probes, and future interstellar missions. Voyager 1 proved that when humans commit to something for the long haul, when we build something designed to last decades instead of just years, we can achieve absolutely extraordinary things. It's not just exploring space, it's showing us what's possible when we dare to think beyond our own lifetimes. So what's really out there? What if everything we thought about the void beyond our solar system was utterly wrong, hiding secrets that could, rewrite the story of the cosmos? Voyager 1's latest revelations are making us question not just what's out there, but why it matters to us down here on Earth. Since crossing into interstellar space in August 2012, this humble probe has shown that the space between stars isn't just a backdrop. It's actually an active player in the grand cosmic drama. It turns out our local bubble, that vast cavity carved by ancient supernovae, is more than a quiet neighborhood. It's a cosmic sanctuary, offering a relatively calm environment where our solar system could flourish undisturbed by stellar storms. But the bombshell? Voyager's plasma wave instrument recorded a sudden change in plasma density last year that hinted at a hidden reservoir of charged particles, what scientists now call the cosmic oasis. This oasis isn't just a neat trivia fact, it suggests that regions like ours might be rare havens where life stands a fighting chance. If other star systems find themselves in harsher, more turbulent pockets of the galaxy, the odds for life there could be dramatically lower. In short, Voyager 1 has given us our first glimpse of the galaxy's real estate market, and it appears we snagged one of the prime lots. As humanity looks toward future interstellar missions, these findings will guide us toward the most hospitable regions for exploration, and maybe one day, colonization. Our little golden messenger has not only mapped out the highways between the stars but also pointed us to the best rest stops along the way. The technicals. Ever wondered how 1970s technology is still outsmarting the most advanced computers we have today while floating in the cosmic darkness 15 billion miles from home? Voyager 1 is, well, essentially a flying museum of ancient tech that's performing miracles every single day using components that were cutting edge when disco was king. This incredible machine runs on a radioisotope thermoelectric generator that converts radioactive decay directly into electricity. A power source so reliable it's been humming along for almost half a century without missing a beat. The plasma wave subsystem, magnetometer, cosmic ray subsystem, and low-energy charged particle instrument are all functioning way beyond their planned lifespans, using integrated circuits and computer processors that, honestly, have less computing power than your smartphone's calculator app. The spacecraft's attitude control system relies on hydrazine thrusters, basically tiny rocket engines, to keep its high-gain antenna pointed precisely at Earth across the vast emptiness of space. Here's the mind-blowing part. Every component on Voyager was designed using slide rules and mechanical calculators by engineers who had never seen a personal computer. The fact that this 1977 masterpiece can still transmit coherent data across interstellar distances using technology that predates the internet is absolutely staggering. It's like watching a rotary phone successfully make video calls to alien civilizations. Proof that brilliant engineering and solid craftsmanship can outlast any technological trend. Digital CPR aftermath and data recovery. What if I told you that the most dramatic tech resurrection in history happened 15 billion miles away from Earth, and the aftermath revealed decades of lost scientific treasures that we thought were gone forever? After months of digital CPR on Voyager 1, NASA engineers didn't just bring their dying patient back to life, they managed to perform the equivalent of digital archaeology on a spacecraft that's further from home than anything humanity has ever built. The data recovery process that followed Voyager's November 2023 crisis was like opening a cosmic time capsule that had been sealed for years. Engineers discovered that Voyager's memory banks had been quietly storing scientific measurements from interstellar space that had never been transmitted back to Earth. We're talking about plasma density readings, magnetic field data, and cosmic ray measurements that filled in crucial gaps in our understanding of the space between stars. The recovery team had to develop entirely new error correction techniques and data reconstruction methods that had never been tested on such ancient hardware. They essentially became digital detectives, piecing together corrupted data fragments like assembling a cosmic jigsaw puzzle. The most incredible part? This entire data recovery operation has become a masterclass in long-distance troubleshooting that will guide future deep space missions for generations. Voyager 1 didn't just survive its digital near-death experience, it emerged stronger, with a treasure trove of previously hidden secrets about interstellar space that are still being analyzed today. The Cosmic Oasis Revelation. What if humanity just discovered that we've been living in the cosmic equivalent of a 5-star resort this entire time, and we never even knew it? Voyager 1's most groundbreaking revelation isn't just about what's out there in interstellar space. It's about the incredible realization that our local bubble is actually a cosmic oasis, a rare sanctuary in the galaxy that's been protecting and nurturing life on Earth for millions of years. The plasma density measurements and magnetic field data that Voyager has been beaming back are showing us that our solar system isn't just randomly floating through space. We're residing in one of the galaxy's most exclusive neighborhoods. This 300 light-year-wide bubble, carved out by ancient supernova explosions, has created a relatively calm region of space that's shielded us from the harsh galactic cosmic rays and interstellar storms that bombard most other star systems. The particle densities and magnetic field configurations in our cosmic oasis are so perfectly balanced that they've allowed our solar system to develop and evolve without major disruptions for billions of years. It's like discovering that Earth isn't just in the Goldilocks zone around our sun. Our entire solar system is in the Goldilocks zone of the galaxy. This cosmic oasis revelation suggests that regions like ours might be incredibly rare cosmic havens where life has the best chance to emerge and thrive, making us not just lucky to exist, but extraordinarily privileged to call this corner of the universe home. Before you go, remember this. Voyager 1 has shown us that space is a dynamic, ever-changing frontier filled with mysteries waiting to be unraveled. If you're as amazed as we are by our cosmic oasis and interstellar revelations, make sure you're part of the journey here on InnoVision Tech. Hit that bell icon so you never miss an update, subscribe for cutting-edge space and tech insights, and let us know in the comments, what discovery blew your mind today? Until next time, keep looking up. What if I told you that in 2017 humanity received its first confirmed visitor from another star system, and we almost missed it completely? This mysterious object, traveling at 26 kilometers per second, defied every law of physics we thought we understood, accelerating away from the sun without any visible explanation. Here's the mind-blowing part. Some of the world's top scientists now believe we may have just witnessed our first encounter with alien technology. Did you know that Oumuamua is still the only confirmed interstellar object we've ever detected, and it's already gone forever? Oumuamua initial detection. On October 19, 2017, the universe delivered humanity its first confirmed interstellar messenger, and it caught us completely off guard. The Pan-STARRS telescope in Hawaii was conducting routine asteroid surveys when astronomers Robert Warwick and his team spotted something extraordinary streaking across the starfield at unprecedented velocity. This wasn't just another space rock cataloged in their database, it was moving too fast, coming from the wrong direction, and following a trajectory that immediately screamed outsider to anyone familiar with solar system dynamics. They named it Oumuamua, a Hawaiian word meaning scout or messenger from afar arriving first, recognizing that this discovery would fundamentally change our understanding of what lurks in the spaces between stars. Within hours of the initial detection, telescopes around the world were frantically tracking this mysterious visitor as it hurtled past Earth at 26 kilometers per second, speeds that dwarfed anything gravitationally bound to our sun. The object had already completed its closest approach to our star and was racing toward the outer solar system, giving scientists only a precious few weeks to study it before it vanished forever into the cosmic void. What made this discovery truly groundbreaking wasn't just that Oumuamua came from another star system, it was the first interstellar object ever detected passing through our cosmic neighborhood, opening an entirely new field of astronomy and raising profound questions about what else might be drifting silently through the galaxy, undetected by our current observation methods. Classification challenges. The moment scientists began analyzing Oumuamua's properties in detail, they realized they were dealing with something that defied every classification system developed over centuries of astronomical observation. Initially tagged as Asteroid A/2017 U1 based on preliminary observations, the object quickly demonstrated characteristics that challenged this hasty designation. Unlike typical asteroids which maintain relatively stable brightness patterns as they rotate, Oumuamua's luminosity varied dramatically by a factor of 10 as it tumbled chaotically through space, suggesting an extremely unusual elongated shape that was unprecedented in solar system astronomy. Even more puzzling, despite approaching within 0.25 astronomical units of the Sun, close enough to vaporize surface materials on most comets, it displayed absolutely no coma, tail, or any other signs of outgassing that should accompany such solar heating. NASA's Jet Propulsion Laboratory and international astronomy teams spent months in heated debates, frantically analyzing spectroscopic data and photometric measurements while flip-flopping between asteroid and comet classifications as new observations contradicted previous assumptions. The confusion reached such levels that by 2018, the International Astronomical Union was forced to create an entirely new category, officially designating it 1I/Oumuamua, the one eye indicating the first confirmed interstellar object and establishing a new nomenclature system for future discoveries. This classification nightmare highlighted how woefully unprepared our taxonomic systems were for objects originating beyond our solar system, forcing the scientific community to acknowledge that Oumuamua might represent a completely unknown class of celestial bodies formed under conditions and processes entirely different from anything occurring within our sun's gravitational influence. Trajectory analysis. When astronomers reverse-engineered Oumuamua's cosmic journey using sophisticated orbital mechanics calculations, they uncovered an epic tale spanning potentially millions of years across the vast emptiness of interstellar space. The comprehensive trajectory analysis performed by international teams at ESA's European Space Operations Center and NASA's Jet Propulsion Laboratory revealed that this interstellar wanderer had been drifting through the galaxy long before our solar system had even settled into its current configuration of planets and orbital resonances. Using precise astrometric measurements from multiple observatories, researchers initially calculated that tracing its path backward pointed toward the direction of Vega in the constellation Lyra, one of the brightest stars in our night sky. However, deeper analysis incorporating proper motion corrections and galactic rotation models revealed a far more complex story that challenged simple origin theories. The object would have needed approximately 600,000 years to travel from Vega's current position to reach our solar system, yet stellar motion calculations proved that Vega wasn't located in that position 600 millennia ago due to the constant movement of stars through galactic space. This startling discovery proved that Oumuamua was a true galactic nomad with no clear stellar home, having wandered through multiple stellar neighborhoods during its cosmic odyssey. Its hyperbolic trajectory, a mathematically defined path that curves around the sun once before heading back to interstellar space forever, indicated approach speeds of 44 kilometers per second relative to our sun at perihelion. Unlike the elliptical orbits of comets and asteroids gravitationally bound to our star, Oumuamua possessed more than enough kinetic energy to escape permanently into the cosmic wilderness, never to return to our solar system again. Photometry and shape analysis. The light measurements of Oumuamua revealed, honestly, the most bizarre shape ever recorded for any natural object in our solar system. Photometric observations conducted by observatories all over the globe, including the Very Large Telescope in Chile and Gemini Observatory in Hawaii, showed brightness variations that, well, could only be explained by an extremely elongated form. Scientists calculated that Oumuamua was at least 10 times longer than it was wide, with dimensions roughly 400 meters by 40 meters, kind of resembling a cosmic cigar tumbling end over end through space. Dr. Karen Meach from the University of Hawaii led international teams analyzing these light curves, discovering the object completed one full rotation every 7.3 hours. The extreme aspect ratio was totally unprecedented. No known asteroid or comet even came close to such proportions. Some researchers, including Dr. Shmuel Bieli, proposed it might be even flatter, resembling a cosmic pancake rather than a cigar, which honestly would make it even more unusual. The surface appeared reddish, similar to objects in the outer solar system that have been darkened by cosmic radiation over billions of years. However, Oumuamua reflected only about 4% of incident sunlight, making it darker than charcoal. This combination of extreme elongation, dark surface, and rapid tumbling motion created a unique signature that really challenged existing models of how small bodies form and evolve in space, suggesting formation processes completely unlike anything occurring in our solar system. Acceleration anomaly. The discovery that, honestly, shattered every conventional explanation came when precise tracking revealed Oumuamua was accelerating away from the sun in ways that just defied physics. Dr. Marco Michelli and his international team published their groundbreaking findings in Nature journal in June 2018, documenting a small but measurable non-gravitational acceleration of approximately 4.92 times 10 to the -6 meters per second squared. This wasn't measurement error. Multiple independent observations confirmed that Oumuamua was actually speeding up as it moved away from our star. For typical comets, acceleration like this makes perfect sense. Frozen gases sublimate near the sun, creating jets that act like tiny rocket engines. However, Oumuamua showed absolutely no signs of this outgassing activity. No visible coma, no tail, no gas emissions detectable by any instrument. The Hubble Space Telescope conducted follow-up observations that confirmed the anomalous motion while ruling out systematic errors or unknown forces. This acceleration was too large to be explained by solar radiation pressure alone, yet too small to be caused by gravitational influences from planets or other bodies. The mystery deepened when scientists realized that whatever was causing this acceleration appeared to be acting continuously and smoothly, rather than in bursts typical of comet outgassing. This unprecedented behavior forced astronomers to consider possibilities they had never seriously contemplated. Either Oumuamua represented a completely unknown type of natural phenomenon or, well, something artificial was responsible for its strange motion through our solar system. Spitzer observations. NASA's Spitzer Space Telescope conducted humanity's final attempt to solve the Oumuamua mystery before the object disappeared forever beyond the reach of Earth's instruments. During November 2017, this infrared observatory pushed its capabilities to the absolute limit, conducting some of the most sensitive thermal measurements ever attempted on such a distant small object. Dr. Davide Farnochia and his team at JPL analyzed the resulting data, hoping to detect the warm signatures of outgassing that might explain the acceleration anomaly. Instead, Spitzer's observations only deepened the puzzle. The telescope detected virtually no thermal emission from Oumuamua, setting strict upper limits on any dust or gas production. If the object were behaving like a normal comet, even minimal outgassing should have created detectable infrared signatures, as solar heating warmed expelled material. The absence of such emissions meant that if outgassing was responsible for the acceleration, it had to be composed of materials completely invisible to infrared detection. Spitzer's measurements also refined estimates of Oumuamua's size and reflectivity, suggesting it was smaller than initially calculated, possibly only 100 to 200 meters in its longest dimension. This smaller size would actually amplify any outgassing effects, making the lack of detectable emissions even more mysterious. The final Spitzer observations in January 2018 showed Oumuamua continuing its anomalous acceleration while remaining thermally invisible, leading scientists to conclude that conventional comet behavior could not explain this object's properties and motion through our solar system. Artificial origin hypothesis. When every natural explanation failed, Harvard University's Professor Avi Loeb and postdoctoral researcher Shmuel Bialy proposed the unthinkable in a paper published in the Astrophysical Journal Letters in October 2018. They suggested that Oumuamua might actually be artificial, specifically a light sail created by an extraterrestrial civilization. This hypothesis, honestly, elegantly explained the acceleration anomaly. A thin, flat object could be pushed by solar radiation pressure without requiring any outgassing. For this mechanism to work, Oumuamua would need to be incredibly thin, less than 1 millimeter thick, while still maintaining its observed dimensions. Loeb proposed it could be debris from alien technology, possibly millions of years old, just drifting through space like cosmic junk from a long-dead civilization. The light sail hypothesis explained not only the non-gravitational acceleration, but also the object's extreme elongation and its unusual tumbling motion. Dr. Loeb argued that extraordinary claims require extraordinary evidence, but, extraordinary evidence also requires extraordinary hypotheses. The scientific establishment reacted with fierce criticism, with many astronomers arguing that invoking alien technology violated Occam's razor, the principle favoring simpler explanations. However, supporters pointed out that dismissing the possibility without proper investigation could actually represent a form of cosmic prejudice. The debate raged across scientific journals and conferences, with researchers split between those demanding more conventional explanations and others willing to consider that humanity had encountered its first piece of alien technology, even if we couldn't definitively prove it. Dark comet theory. Dr. Daryl Seligman from the University of Chicago proposed a revolutionary alternative that really challenged our understanding of comet composition and interstellar chemistry. The dark comet hypothesis, which was published in the Astrophysical Journal back in 2020, suggested that Oumuamua could actually be made mostly of frozen molecular hydrogen. In the extreme cold of interstellar space, where temperatures are around 14 Kelvin, hydrogen can freeze into solid ice that would stay stable for millions of years. As Oumuamua got closer to our sun, this hydrogen ice would sublimate directly into gas, But unlike water vapor or other typical comet materials, hydrogen gas is almost completely invisible to most astronomical instruments. This invisible outgassing could explain the mysterious acceleration without creating any visible coma or tail. The theory goes on to suggest that Oumuamua formed billions of years ago in a giant molecular cloud. Those vast regions of space where gas and dust come together before forming new stars and planetary systems. These environments could create really unique conditions for hydrogen ice to build up, making objects unlike anything we've seen in our own solar system. Seligman's calculations showed that a hydrogen iceberg about the size of Oumuamua could stay intact during its journey through interstellar space, and provide enough outgassing to explain the observed acceleration. This hypothesis opened up the possibility of an entirely new class of interstellar objects that might be drifting undetected all over the galaxy, basically invisible to our current observation methods, because their outgassing doesn't produce any visible signatures that our telescopes can pick up. Dark comet classification. The implications of the dark comet theory went way beyond just Oumuamua. It could totally revolutionize the way astronomers classify small bodies in space. Researchers at NASA's Jet Propulsion Laboratory started developing new classification systems to account for objects that show non-gravitational acceleration, but without any visible activity. Scientists began to propose distinguishing between small dark comets like Oumuamua, which came from interstellar space, and potentially large dark comets that might actually exist within our own solar system, just unrecognized up until now. Dr. Darrell Seligman and his colleagues even identified several objects in the solar system database that showed unexplained acceleration without obvious outgassing, suggesting that dark comets might be way more common than we ever imagined. The new classification parameters included things like thermal emission signatures, spectroscopic properties, and acceleration magnitudes that are really different from what we see with traditional comets and asteroids. This new framework suggested that maybe our telescopes have been missing a whole population of hydrogen-rich objects simply because our detection methods are tuned for water-ice comets and rocky asteroids. The European Space Agency even started to include dark comet detection protocols in their future mission planning, realizing that interstellar visitors could be a lot more common than just the single confirmed case of Oumuamua. Some researchers estimated that if the dark comet hypothesis is correct, the galaxy could have billions of these invisible objects, creating a hidden population of interstellar wanderers that occasionally pass through planetary systems without us even noticing. This whole idea really changes our understanding of how material is distributed across the galaxy, and it suggests that the space between stars could be way more crowded with small bodies than our astronomical models had predicted. Scientific debate. The Oumuamua controversy has basically split the astronomical community into competing camps, each one defending some pretty radically different interpretations of the same data. Team Natural, led by researchers at NASA's Goddard Space Flight Center and the European Southern Observatory, insists that conventional physics has to explain the acceleration anomaly, and they propose things like outgassing of common volatiles or internal changes during solar heating. Then there's Team Artificial, led by Harvard's Avi Loeb and backed by researchers from Tel Aviv University, who argue that the light sail hypothesis deserves serious scientific consideration, and shouldn't just be dismissed because people are skeptical about extraterrestrial explanations. Team Dark Comet, centered around researchers at the University of Chicago and Yale University, is pushing the hydrogen iceberg theory and working on ways to detect similar objects. The debate has been going strong in top scientific journals like Nature, Science, and the Astrophysical Journal since 2018, and honestly, each new analysis seems to make the mystery even deeper. Dr. Alan Fitzsimmons from Queen's University Belfast leads the skeptics, saying that these exotic explanations go against scientific principles, while Dr. Abraham Loeb's supporters counter that extraordinary evidence demands extraordinary hypotheses. Recent studies have even found more solar system objects with similar properties, which could support the dark comet classification. The scientific process is working exactly as it should. Competing hypotheses are driving new observations and new theories. Whether Oumuamua was natural, artificial, or something totally unprecedented, it's already changed astronomy by showing that interstellar objects can really challenge our most basic assumptions about the universe, forcing scientists to broaden their frameworks for understanding cosmic phenomena. So, there you have it. Oumuamua is still one of the greatest mysteries in modern astronomy, challenging just about everything we thought we knew about interstellar objects. Whether it was a natural dark comet, alien technology, or something completely unprecedented, this cosmic visitor has forever changed the way we see our place in the universe. What's your theory? Was Oumuamua our first glimpse of extraterrestrial engineering, or does nature still have more surprises up its sleeve? Drop your thoughts in the comments below. I read every single one. And if you're fascinated by these mind-bending space mysteries, go ahead and smash that subscribe button and hit the bell icon so you never miss the latest discoveries from InnoVision Tech. Until next time, keep looking up.